Good day everyone, welcome back to this channel. Our lecture for today introduces the basic concepts and syntax of programming. These are the fundamental rules and structures that allow us to write programs or a computer can understand. So we'll start with the key building blocks like variables, data types, and operators, which we'll use throughout this lesson. So by the end of this lesson, you'll be able to understand and declare variables, work with different data types like int, integer, float, double, and char, perform input and output using scanf and printf, and using and executing arithmetic operations in C programs. Here, just in case, before we dive into variables and data types, we have formats and comments. So formats helps us control how text appears on the screen. So for example, if I want to move to a new line, I use \n. If I want to add tab space, I use \tab. So comments are notes we leave in the code to explain what's happening. They don't affect the program's execution. For a single line, we use /, and for multiple lines, we enclose the text between open /* and close it with */. So using comments makes your code easier to read and understand for other programmers or developers. So here's the example on how to use a single line comment and a multi-line comment. So from line 4, you have this is a single line comment, so you use a /, and for the multi-line comment, you use this if you want to place some paragraphs or longer sentences. Then you'll use this multi-line comment. Then this is the example. So only /* and close with */. So that is the example on how to use a single line comment and multi-line comment. Now, let's talk about variables in C. A variable is basically a name storage location in memory that holds data, and this data can change while the program runs. So in short, variable is a container. A container has a value or not. So that's the short definition of what is a variable. If you don't understand any variable, I'll explain it to you later. So first is we have 3 things to know about variables. First, declaration. This is when we tell the compiler the variable's name and type. Second is initialization, giving the variable its first value. And third, assignment. So assignment means changing the variable's value as the program executes. So I have example image here. What are the 3 things in variable? So first we have variable declaration. So you can see here I have this data type int and a variable name number and a semicolon. So this is variable declaration, meaning this declares a variable named number of type int. Int means integer. So at this point, number has no value yet. This is a garbage value, so we don't have value for our variable named number. So that is a variable declaration. Next, we have a variable initialization. So this is the variable initialization. You have variable name age with a data type int and has a value 25. So this both declares and assigns a value in one step. Variable age is created and immediately given the value 25. So from the word initial in initialization, you're declaring a variable name age with a data type int and has an initial value that is 25. So also do not forget putting a semicolon after giving a value. So that is variable initialization. Next, we have variable assignment. So variable assignment here is we have age is equal to 30. So here we change the value stored in age to 30. Now age does not store 25 anymore. It stores 30. So you can see here we didn't declare a data type na because we have already initialized at the line 16. So if you want to change the value of age, all you have to do is just place the variable name and put an assignment operator, then add any value you want for this variable age. So that is variable assignment. Note, do not declare or initialize a variable if you already declared that name variable. Okay, that's the rule in every programming language, because the computer might confuse, like you already declared the variable. Let's say you already declared a variable number, then you declared a variable which is number, which is int number is equal to 25, yet you already declared here. So the computer might confuse that. So what you'll do is you'll just have to use variable assignment if you want to change the value or assign that declared variable. So that's the three things in variables. Now let's look at identifiers in C. So an identifier is the name we give to a variable, a function, or any user-defined item. It must start with a letter or an underscore and can be followed by letters, digits, or an underscores. We cannot use punctuations like at, $, or percentage in identifiers. Also, C is case sensitive. So this means that if you have a variable named manpower and you have also another variable named manpower with a small letter m, I mean the first manpower is capital M and you have a manpower that is small letter m, that would be considered two different identifiers. So choosing clear and meaningful names helps make your code easier to read and understand. So here are the examples of acceptable identifiers. So we have here, this is acceptable because you start with a letter or an underscore. So remember, the acceptable identifiers start with first letter and or underscore. So here are the examples of not acceptable identifiers. So you can start with letter, but you're using special character. This is not unacceptable. Also remember at the below, no special characters allowed when naming a variable. So no $, no punctuation, nor percentage must be used when you're making a variable name. Now we all understand how to place comments, what is a variable, and what is identifiers. Now we'll discuss the basic types in C. First, int, which is here, is used for whole numbers. And it's here in the scripture, integer values. An example initialization here, we have int age 30. So you can see it's whole number only. So you can use negative value or positive value, but also remember it should be whole number. And the memory size of int is 4 bytes. Next, we have float. Float is a single precision decimals. So we have here float salary is equals to 4,500.50. So we're using decimal here. So by using decimal, we'll have a data type float. So 4 bytes is the memory size for data type float. Next, we have double. Double precision decimals. So we have double pi is equal to 3.14159. The difference between float and double is that double provides more precision. So by using double, you have memory size of 8 bytes. Finally, the char. Char is used to store a single character. So you can see the example in here, example initialization. So I have a data type char, variable name grade, and a value of a. That is a single character. So you cannot use 2 letters or 3 letters, just single character. And the memory size is 1 byte. So here's the example again in detail about data types, including initialization and example. So here, if the computer runs, let's say we compile and run. First, it checks include stdio. Next, it reads int main. So this is the starting point of every C program. Then the computer reads here, which you can read variable name student count with a data type int and as a value 45. So int means integer, whole numbers without decimals. Here we created a variable named student count and stored the value 45. So next is float. Float means numbers with decimals but not very precise. We have here average score stores 87.5, which is a decimal number. Next, double. Double is like a float but with double precision. More accurate decimal places. Let's say we have a variable named precise pi, stores a longer version of the value of pi. Char letter. Char is for storing a single character, letter, number, or symbol. Letter grade stores the character B. So this is the value of letter grade. And return 0. This ends the program and tells the computer it runs successfully. Now we have some advanced or derived data types. So we have here an array is a collection of elements that are all of the same type. It allows us to store multiple values under a single name. So next is we have a pointer. A pointer is a variable that stores the memory address of another variable. Pointers are very powerful because they let us directly access and manipulate memory, which can make programs more efficient. We continue with advanced data types, focusing on type modifiers. Short is used for smaller integers, long for larger integers, and unsigned allows only non-negative values. Type modifiers helps us control the range and memory usage of our variables, which is useful for optimizing programs. So here we have the example. First is short age. Short is usually used 2 bytes of memory. It can store smaller range of numbers compared to a normal integer. Example, age is equal to 25. Next is we have long, a data type long with a variable named distance and has this value. So long usually uses 4 or 8 bytes depending on the system. It can store much larger numbers compared to int. An example here is distance is equal to 1,500,000. So the L, you can see here, after a sign operator, we have an L at the last, tells the compiler that this number is long. So that's what it says to our compiler. Unsigned int count. So unsigned means the variable cannot store negative numbers. It only stores 0 and positive values. So example, count 100. Next, we have unsigned char letter and has a value of 65. Char normally stores a single character, one byte. By default, it can store both negative and positive values. but unsigned car only stores only 0 to 255. Here letter 65 in ASCII, 65 represents A. Now let's talk about output using the printf function. We use printf to display information on the console. Its basic syntax is print format string arguments. The format string can include the format specifiers, which tell C how to display the values we provide. For example, D is used for integers, address operator F for floating point, the percentage F for floating point numbers, and percentage C for characters. We'll see examples shortly to make this clearer. So here's another example in detail on how to initialize variables and print with appropriate format specifier. So let's say step 1, we have declare and initialize variables. We have variable name student age with a data type int and as a value 20. This is whole number. We have a variable name exam score with a type float and as a value 85.75. This is a decimal number float. We have a double bank balance. This is the value, high precision decimal, and car, student grade, and as a value A. So this is only single character. Step 2, we'll print each variable with appropriate format specifier. So here we print the student information. We have an age. We use a format specifier D. This indicates that we'll place a whole number here, an integer. Then we place the variable. So based on what you place here from a specifier D and the value of student age will be displayed in the console later. So let's say the value of student age is 20. So when you compile and run the program, it will display age 20 years old because the value of student age is 20. Same with the exam score, 85.75. Using here .2f. 2f shows 2 decimal places only. So if you have another decimal place here, 753, it will only display 85.75, not including the 3, because you're just using the 2f. You're placing 2 only, not 3. Next, bank balance. So same here, 2 LF. LF is for double. When you're placing a value that is double, you'll place .2LF, then the variable. Finally, we have grade, percentage C. This indicates a character. Then the student grade. So it will display in the console A. So this is the example detail output. So you can see here we have age 20 years old, exam score 85.75, bank balance 1,234.57. So you can see it's only 57. It just rounds off because you only place the bank balance 0.2. So 7890 is not included. 7 is high number, so it will round off, so it will display in the console 57. Grade A. So you can see here value of student grade is A. So here's another example of using printf function. So we have initialize 3 variables, int age 25, float height 5.8, car grade single character, and we print the variables. We have format specifier, this is D, 1F, that means only 1. Decimal place shall be included when you print it to the console. We have grade, percentage C, and grade. So here we have printf student info age, percentage d, height, percentage 1f, and grade, percent format specifier c. So you can see here it's basically has many format specifiers, but it still work as long as the placement of your variables is in right position. So let's say the computer will read this percentage d. He'll try to look what is the first variable, so age, he'll place that value here. The height, he'll look at the second variable, he'll place the height here. So that's the grade, he'll place it here. So that's the example of printf function. Next, we have input using the scanf function. We use scanf to read values from the user through the console. The syntax is scanf format string here we have the output based on this code. You have age 25, height 5.8 feet, grade A, then this is it, 25, 5.8, and grade A. Next, we have input using the scanf function. Next, we have input using the scanf function. We use scanf to read values from the user through the console. The syntax is scanf format string variables. So notice the ampersand variable. You can see here syntax scanf format string, comma, then this ampersand variable. This is a address operator. So it tells the C where to store the input value. Without it, scanf won't work correctly. So let's try using the scanf function. So let's say I have to declare 3 variables. That would be int age, float salary, and car grade. So these 3 variables have no value yet, but how do we get the value for this age, salary, and grade? So we'll have to allow the user to input some value and store each of those variables. So say put here, they use comment getting integer input. So let's try to ask the user enter your age. This is the print function, so when you run it, this will display enter your age. So we'll use the scanf function to ask user to input a whole number. So this is the format string, so D indicates that a whole number can only be acceptable. So we'll use scanf to accept user inputs. So first is we add a format string, that is percentage %d. and an address operator then age. So this means that format string D is allowing the user to input whole numbers only. And this address operator and age, meaning for whatever the user inputs a value, it will store at the variable age. So let's try print that. Printf age is, we use the format specifier D, then add variable. So let's try to run that. Then enter your age, let's say 25. Now, why does this happen? Why age is 25? Why it has a value? Because you're allowing the user to input a value. That means I input 25, and the computer gets this 25 value in this area, and he'll store it to the variable age. So here age value is now 25. So that's what happens after inputting a value. So that is for age. Getting the float input, let's ask the user printf enter your salary. Then we'll use a scanf function. So we'll use a format string f, that means float. Then let's store the input value to a variable salary. Next, we have getting the character input. So let's print enter your grade. You use scanf, and when you use a format string character, you have to press space first, then %C. Then we'll store that to a variable grade. Now let's display the input. Printf \n your details, print age %d, this is a format specifier, years \n, then the variable, that is age. Same with the salary %.2f. I've placed here a $sign, or let's say what will happen if there's no $sign, \n. This is a new line, then the variable salary. Next, we use printf for grade, C, then grade. So let's try to run it. So enter your age 20, enter your salary, say 2,500.50, enter your grade P. I don't know if there's a P grade, but it's just a random character I just input. So this is details, 20 years, 2,500.50, and grade P. So and that is how scanf and printf functions. So note that printf function is used for displaying outputs in the console. This is the console. And scanf is used for user inputs. Now, let's cover arithmetic operations in C. So, the basic operators are plus, which is addition. So, example here, 5 plus 3 is equal to 8. Minus, that is subtraction. 5 minus 3 is equal to 2. Multiplication, then 5 multiplied by 3 is equal to 15. Then division is have 6 divided by 3 equals 2. And we have here modulo operator. This is a modulus. So 7 modulo 3 is equal to 1. So what does this mean in modulus? So modulo is basically a division, but the value is based on if there is a remainder or not. So it's similar with the division. Division gets the value when you're dividing, but the modulo is for remainder. So let's say if you have 4 divided by 2, it has 0 because there is no remainder. So that is example of modulo. So important notes here. Integer division discards the remainder. So 7 divided by 2 gives 3, not 3.5. For float division, 7.0 divided by 2 gives 3.5. The modulo operator only works with integers. Also remember that C follows the PEMDAS order of operations, so multiplication and division happen before addition and subtraction. So let's look at the example problem. A rectangle area calculator. So imagine a construction supply shop that wants to help workers and customers quickly calculate the area of a rectangular piece of wood, glass, or metal before cutting it. So your task is to write a program that asks the user to enter the length and width of the rectangle, calculates the area using the formula area is equal to length multiplied by width, and finally display the result showing the entered length, the entered width, and the calculated area. Okay, let's try solving this problem. So the first task we need is to write a C program that asks the user to enter the length and width of a rectangle. So we ask the user to enter the length and width of a rectangle. So length has a decimal places, so we'll declare two variables with a data type float. So float can handle decimal places, so we do not use int here. So it's a float length and float width. So first, these two variables have no value yet, so this is what we call variable declaration. Because it has no value, we just declared if two variables, length and width. So let's do it again. Ask the user to enter the length and width of a rectangle. So let's ask the user to input a length and width and store it to the designated variable. So I say enter the length. We'll use a scanf function. Scanf, use a format string f, then let's store it to a variable length. Same goes with the width. Printf, enter the width, then scanf, format string f, then store to a variable width. So let's try to print it. The length is, let's say, format specifier f, then place the variable here. Don't forget the \n, or else this will not create a new line. Printf, the width is format specifier f, 0.2f, means 2 decimals only, then width. Let's try to test it. Or say the the length is 10.5, then enter the width 15.10. Then this is the input. The length is 10.50 here, the width is 15.10. Now we already finished the ask the user to enter the length with a rectangle. We'll proceed here, calculate the area using the formula area is equal to length and width. So we can follow this formula. So let's declare another variable. That would be float area. And this is we use the arithmetic operator, that is a multiplication. So before the printf, I'll just add here a variable assignment. So this is we use a variable assignment. We do not declare the variable area again because we already declared here at line 24. Then in line 33 we just have to assign the variable area. So variable assignment. So what you'll do is you have just area is equal to length. We use the asterisk, that is a multiplication, and width, then semicolon. So you can see the similarities. They're both the same. Area, length multiplied by width. Then let's try to run it. 10.2, 15.0. So nothing happens. The calculated area doesn't print because we forgot to print it to the console. We just have to print f the calculated area, say percentage 0.2f, then area. So try to run it, then 10.2, 15.20, and it calculates. So 155.04. So what does this happen? How does it work? First is when you run build and run, it checks here include stdio in line 3 int main function. Then the computer goes to the line 22. He reads 3 variables at the line 22 to 24. You're declaring 3 variables, length, width, and area. So the computer knows na okay, you're declaring a variable. Now what line should you assign these some values? So the computer checks here 26, printf, enter the length. So when the computer reads this printf function, he'll display it to the console. This is what happens here. Enter the length, and the computer waits in line 27. So this is where you allow yourself or the user to input some values. Let's say I'm going to input 25. So by pressing enter, it will proceed to enter the width. So the computer understands na okay, you input a value 25. Now I'm gonna store the 25 value to a variable length. So after line 27, the value of the length is now 25. Next, it displays the enter the width. Here he reads it here. Enter the width. Same goes in this line of 30. The computer waits for the input. Then say 11.10. Then by pressing enter, it will automatically displays the length is 25, the width is 11.10, the calculated area is 277.50. So what happens after you input the width is that this 11.10 value will be stored at the variable width. So by the time you finish inputting the value, the computer checks at the line 33. It says here that area equals length multiplied by width. So the computer checks if the length and width has a value. So based on what we input, 25 and 11.10, these are the values. Then it will multiply, and after getting the results, the computer stores it to the area. Then the line 35 to 37, it will print the length is, the width is, and the calculated area. So that's how it works. So that's all for this video. Don't forget to like and subscribe for more contents to be uploaded.